Okay, just want to go over logarithms today. They are a little bit of a hard concept, but what they really are is an inverse function of to the power. So, the inverse function of addition is subtraction, inverse function of multiplication is division, the inverse function of sine is inverse sine, and that's the same thing what a log is. So really the first step in understanding a log is understanding exponents. So really, let me just go over a problem here. If I have 2 to the third, that just means 2 times itself 3 times, 2 times 2 times 2, or 8. If I have 2 to the fourth, that's saying 2 times 2 times 2 times 2 equals 16. So the growth of my outcome is exponential because it's doubling every time. Part of the reason why logarithms are so useful is it helps you solve exponential growth problems. And they're kind of everywhere in science and life in general. The earthquake, the Richter scale, is in fact a logarithmic scale. Music is a logarithmic scale. Logs are essential in pH, acidity, base. Okay, so logarithms are useful because they let you go backwards through an exponential function. So let's just keep looking at this and thinking about this. So what a logarithm really is saying is 2 to what power equals 32. So the way you solve this is with a log, but that's what a log is saying. It's saying my exponent is unknown. What would it have to be to get to 32? So the way I do that is I say, I could just figure out an exact value like this, that this is double 16, so it has to be 2, 4, 8, 16, 32. So 2 to the fifth is equal to 32, so here x would be equal to 5. So the definition of logs, which is probably the most important thing to know, is log base b of y equals x. And what this is saying is this is my base, this is my power, and it's equal to that. So log base b of y equals x is the same thing as b to the x equals y. Okay, so this is, you just kind of have to know this and understand why it works, because what you're doing is writing an exponent in a different way. It allows you to bring that exponent down to a base number. So if I have the question like this, log base 2 of 64, that's just saying the exact same thing, is 2 to what power equals 64. So that's how I bring that exponent down. Log base 2 is 64, I'll set it equal to x. Therefore 2 to the x is equal to 64, and I could evaluate this log by saying 2 to what power equals 64. 2, 4, 8, 16, 32, 64, 2 to the 6. So x is equal to 6. So that's a log, or logarithm. Okay? There are 3 types of problems you're really going to encounter with these functions. And I have 3 problems written down here. And the first one is just saying 20 to what power equals 150. So before I even evaluate this or solve for x here, I'm just going to think about it. 20 to the first is 20. 20 squared is 400. So I'm expecting a value between 1 and 2. The way I solve this is I take the log of both sides. So I do whatever I want to the equation as long as I do it to both sides. I take the log of both sides. The first property of log says x can come down in front. So I bring the x down in front. And now I have x log base 10 of 20 is equal to log base 10 of 150. I want to get x by itself. So I divide both sides by log base 10 of 20. These things right here cancel. So now I have x is equal to log of 150 divided by log of 20. I'm expecting a value between 1 and 2, but I'm going to have to use my calculator. So as I look at my calculator here, I can see the log button is the inverse function of the 10 to the x button. So I'm going to do log of 150 equals divided by the log of 20 equals 1.67. So in this one, my answer is x equals 1.67. When I round with logarithms or exponential functions, I'm going to have exponential error. So if I go back to my original equation, what should happen here is 20 to the power 1.67 minus rounding error should equal 150. So if I store that value on my calculator, I could go 20 to the power of 1.67, and it should equal 150, and it does. I know it's kind of hard to see that. So that's the first type of logarithms. I'm going to talk about this property a little bit more at the end of the video. Then the second type of logarithm problems are really a different base than base 10. So again, I'm going to use the definition of logs to set this up. So this is my base. This is my exponent. 5 to the fourth. 5 to the fourth equals 2x plus 2. 5 to the fourth is 5 times 5, 25. Times 5, 125. Times 5, 625. So 625 equals 2x plus 2. Subtract 2 from both sides. 623 equals 2x. Divide both sides by 2. I'll do that on my calculator. 623 divided by 2. And x is equal to 311.5. So here I'm just using the definition of logs. 5 to the power of equals that. Okay? And then the third kind of problem isn't really an exponential problem. It is an exponential problem, but not a logarithm problem. Here, my unknown variable x is my base. So I need to isolate x. So the first thing I'm going to do is get rid of this 10. Now I have 5 to the power of x plus 3 to the power of 3/4 equals 150. Isolating x, next operation is divide by 5. These will cancel. Now I have x plus 3, the quantity of, to the power of 3/4 equals 30. This is counterintuitive, I think. This is not a logarithm at all. This is to the power of 3/4. If it were squared, you would square root it. So what I'm really going to do here is I'm going to take it to the 4/3 power. If I take it to the 4/3 power, that'll give me x plus 3 to the power of 1. If I do that to the left side, I also have to do that to the right side. The way I enter this in my calculator is 30 to the power of 4 divided by 3. So let's do that here. 30 to the power of the quantity 4 divided by 3, and I get 93.2. So I have x plus 3 equals 93.2. Subtracting 3 from both sides, I have x is equal to 90.2, and that's my answer. So again, I have three types of log problems here. The first is my exponent I'm solving for by using the log of both sides of the equation. First property log, x comes down in front. The second is I'm using the definition of logs, where my base is 5 and my exponent's a number, and I set it equal to that. And then the third is really just an nth power function, power to a number, not a variable. And I reverse my operations, and then I take it to the inverse of this power. So that's how I get rid of those powers. So let me talk a little bit more about the three properties of logarithms. So probably the most important, again, is the definition of logarithms. And that is log base b of y is equal to x. So this is my base. This is my exponent. B to the x equals y. These are saying the exact same thing. Just like what I did with the 2's earlier on. Okay, the power property, sometimes called the first property of logs, or the power property of logs, is log base b m to the n is equal to n, that n comes down in front, log base b of m. The second property of logs, also called the product property, is log base b of m times n is equal to log base b of m plus log base b of n. And then the third property of logs is a quotient property. And this is going to be log base b of m divided by n is equal to log base b of m minus log base b of n. Okay? So these are similar to, well, they're inverse functions of exponents. If I have x to the m to the power of n, this is x to the mn. If I have x to the m times x to the n, just like I'm doing here, I have x to the m plus n. And if I have x to the m divided by x to the n, I have x to the m minus n. I subtract my exponent. So I guess the first step is really knowing your exponents really well. The second step is understanding what a logarithm is and the definition of a logarithm, that you could go back and forth between these two. And then learning the three properties of logarithms, the power property, the product property, and the quotient property to solve equations. Okay, well, hopefully that's a good start. Good luck.